Hello, this is an A-level maths video. It's based on the pure maths content of year 1. We're looking at chapter 1 of the textbook, section 1.5, and this is all to do with surds. So here's the first question of this video. What is the exact value of the square root of 2? I've given you some options there, so please pause the video, have a think about it, and once you've got your answer, restart the video. Right, well I think we need the calculator to help us with this one. So on the screen I've got my calculator emulator up. I'm just going to put in the square root of 2 and see what the calculator gives me here. So root 2 equals, well it's just giving me root 2 here, so let's see what that looks like as a decimal. And the calculator's given me that answer there, 1.414213,562. So I wonder if you did that, and if you did you then go for the answer here, 1.414213,562 as the exact value of the square root of 2? Well, unfortunately, that's not the right answer. The correct answer is none of the above numbers are equal exactly to the square root of 2. And the reason for that is because the square root of 2 is actually one of these numbers which has a decimal expansion which literally goes on forever. It never stops. It's a bit like the number pi. So our calculator gave us the answer it did, but it only gave us the first few decimal digits because that's all it could display on its screen. The true result of the square root of 2 is a number which literally goes on forever. So for that reason, it's really important that we can do calculations and manipulate these numbers, which are square roots of numbers, without having to turn them into decimals. And this is really what we're going to be covering in this video. So when we have a square root or any kind of root, a number which literally goes on forever as the decimal expansion, we call those kinds of numbers surds. So there's a technical definition on the screen there involving things called rational numbers. If you are not familiar with that idea of a rational number, it's a number that can be written as a fraction with integers essentially. But if you can't simplify a root expression to a rational number, then we call it a surd. So, quick test for you. I've put 4 numbers on the screen there. Some of them are surds and some of them are not surds. Sort out which is which, please. Okay, how did you get on with these? So I will just tell you that the square root of 2 and the square root of 12 are both surds, whereas the square root of 25 and the square root of a quarter, these are not surds because you can simplify both of those. The square root of 25 is of course 5, because 5 multiplied by itself gives you 25. And then the square root of 1 over 4 here is 1 over 2, because when you multiply 1 over 2 by itself, you get 1 over 4. So these ones are not surds. Okay, you familiar with that definition? Hopefully. You're probably already familiar as well with these rules to do with surds that I've put on the screen here. We can manipulate surds using the following rules. Now, we're not going to prove them in this video, although they're not too difficult to prove if you write them in indices form. But we'll have a look at 1 or 2 questions together for the rest of this video, get a bit more practice and make sure that we can use these rules in all the ways that we might want to. So there's a question on the screen right now. Let's see what you can do with this one. Pause the video, have a go at it, prove the result that's there. Okay, let's see how this one works. So I think there's a couple of different ways you could approach this one. I think the easiest way is probably to just use that first rule on the screen there directly. So we will just say that the square root of 18 multiplied by the square root of 2, we can write that as the square root of all of 18 multiplied by 2. So that's just using that first rule on the screen there. Let's do the calculations. 18 times 2 is of course 36. And the square root of 36 is 6, because when you multiply 6 by itself, you get to 36. Okay, did you get that one right? Here's the next one. This one's a division. Let's see how you get on with this one. Okay, so here we go with this one. Same numbers, this time we're just dividing one by the other, aren't we? So let's write this down. The square root of 18. Now if I write it as the division as a fraction here, we can see how it might relate to the rule that's on the screen a bit more easily here. So the square root of 18 divided by the square root of 2, we can use the rule and say, well, that's going to be the same as the square root of 18 divided by 2. Of course, 18 divided by 2 is 9, and the square root of 9 is 3, because 3 multiplied by itself gives us the answer 9. So we've shown what we need to show. Here's the next one for you. Do you remember how these ones work? Pause the video, have a go at this one, make sure you write down all of the steps of the process, and restart once you've done that, please. So do you remember how these ones work from your previous studies? I hope so. Let's just quickly go through it, just in case you're unsure or you want to check what's going on here. So the square root of 45, we want to show that equals 3 times the square root of 5. So the trick is that we're going to write 45, we're going to split it up into factors. And I'm going to split it up into the factors 9 times 5 here. The reason why I've chosen 9 is because 9 is a square number which I can take the square root of very easily, and this is how it works here. We use that first rule on the screen backwards to split the 9 times 5 up into 2 separate roots like this, and then of course the square root of 9 is 3, and then we've got the square root of 5 there, and we're done. How are you finding it so far? All pretty straightforward, or having to think about it a bit? Well, we've just got one more we're going to do in this video. This one on the screen right now I think is a little bit more complicated. You might have to go through a couple of stages here, but see how you get on with this one. Here we go then, let's see how we got on. So let's start off with the expression we've got here on the left hand side of our equation up there. So root 3 plus root 2, and we need to square that. So remember, squaring just means multiplying by itself. So I'm going to take the root 3 plus the root 2, and I'm going to multiply it by another root 3 plus the root 2. Okay, so I think the next thing I want to do is just expand out the brackets. So root 3 times root 3. Well, of course, the definition of a square root is when you multiply that number by itself, you get back to that original number here, which in this case is 3. So that's what we're going to have when we multiply root 3 by root 3. The next term, root 3 times root 2, well, that's going to be the same as root 3 times 2 inside the square root. So that's using that first rule there. Where are we? So next term we want is the root 2 times the root 3. So we've got 2 times 3 inside the square root here. And then finally, the last term, root 2 times root 2, which is of course just 2. Okay, so let's continue. I can certainly collect the 3 and the 2 together to make 5, and I'm happy about that because I can see 5 is part of the answer I want. Here I've got 3 times 2 is 6, and of course 2 times 3 is also 6, so I've ended up with 2 root 6 here. So comparing this with what I want to look like, I've just got to show that the 2 root 6 is the same as the square root of 24. And I can do that if I do a clever thing here and write 2 as the square root of 4. Because I can say that this term here is going to be the square root of 4 times the square root of 6. And finally, using that first rule on the list on the screen there again, we can write that root 4 times root 6 as root of 4 times 6, and 4 times 6 is of course 24. So how was all that? Anything there which was unfamiliar to you? I hope not. I think if you're starting an A-level maths course, you should be familiar with those rules already. But if you do want to get a bit more practice, exercise 1E of the textbook is where to go on page 13. But that's the end of this video, and I'll see you again shortly.